So, hey guys, it has been 8 months, I think, since the last time we were able to kind of gather here in solemnity and work together. Um, I don't actually know how to explain it, but it's been hectic. At work, I was reassigned from my development team onto a DevOps team, kind of with a view towards upskilling. So I was previously just doing dev work. I was doing full stack dev work. Um, they moved me into DevOps after having a long, complicated conversation about where I see myself in the next couple of years. And given that the thing I was doing like sole development on, that project kind of fell by the wayside because the what do they call those people? The angel investor. He decided he's going to pull out funding because I think the pandemic just hit and just things started going funny. So um, that kind of fell by the wayside. And because I was the sole developer, I was kind of repurposed into something. They couldn't decide the something because I fit on like 3 or 4 teams. So they had a discussion with me. I said that I want to kind of go up a level. That development work is a little bit, I don't want to say it stagnates or it becomes stale, but it does become kind of repetitive after a while. So they moved me to a DevOps team, and that's just been blasting my mind. Like previously, I looked down on the DevOps guys. I was like, not really developers. They just do whatever. But my word, I have a newfound respect for them because on day one, today you'll be facing some Kubernetes problem, and then on day two you'll be working in Docker, and day three you'll be working with Argo, and day four you'll be working in like freaking GCP or AWS or wherever, right? So it's any tech, so they have to have a lot broader skill set. But not only that, the DevOps team I was put on is actually it's a bunch of full stack devs with a primary focus on Java. So these people are all highly skilled. So I've just been playing catch up for like the past like the past almost year. I've just playing catch up. So everything kind of just got set aside. We haven't been making videos on my family channel for a while. We haven't been doing trips. We haven't been doing a lot of things that previously we would have been doing. So I mean, with all that happening, there was also the shift from whatever we were doing currently into the lockdown levels that just kind of threw everything basically just down in the gutters. A bunch of places closed down around us. A bunch of my friends, they got retrenched from the jobs. It's just been difficult for everyone. So I haven't actually been doing my videos as I should. I mean, it's very hard to find time in any case. We've been doing a bunch of renovation on the house. I don't want to say renovation. I want to say we're completing it, right? We're doing painting, plastering, all the bits that we exposed. We're nearly there. I just finished off the last of the electrical work like yesterday. One of my inverters died. So it's been a busy couple of months, but also it's been a stressful couple of months. So with that said, I think I rewatched my previous attempt at helping. Everyone understands C++. We kind of left off with this mess, right? Let's just run it. We kind of left off with this. So what we have here is we have our bounding volumes defined, we have our paddle defined, we have our ball defined. I guess there's input happening somewhere, but there's not really much interesting happening here. We previously had this working, bouncing, doing all kinds of things. We don't have that now. So I think you can see it's a little bit late, so I just want to take some time quickly to finish off some stuff. I haven't looked too much at the code, so let's kind of just catch up together, right? So we had this idea that our collidable thing would kind of just a collidable thing would work this way, right? Our access aligned bounding boxes, we got a collided function. Let's just close the object browser. Let's just look at the CPP file. CPP file has a simulation. I don't know if you guys are watching Solar Opposites, but my word, season 1 was amazing. Season 2, questionable few moments in there. I don't want to spoil anything, but things get weird. But in season 1, just the humor, it's so nice. So let us start by having our simulation. update and draw. Let's just go inside the go to definition, F12, update and draw gets update everything, mouse here, and then fill my rect with my 4 walls, more drawing here. So that I'm assuming this would be the blocks that go here, so that's fine. Let's get the idea. We got the walls and we got a whole bunch of intersections. So this is actually what would happen if we go and fill in those get collision response bits and pieces. There would be things happening, right? So that's all fine. I'm not too stressed about it, but I do know that we have a bunch of work cut out for us, like a lot of work. I think the last video in the series was cleanup, and cleanup was not going as well as I'd hoped, right? There was still a lot of work to be done by the time I finished off that video. So let's just kind of try and get this sorted out. So I think the first thing I wanted was just for the collidable to have this collision man thing. The collision checker is I'm not happy with how the collision checker works. Okay, so I guess one of the first things I want to do is I want to have a public stat is collision 1 is collision checker started collision checker. Oops, sorry about that. The laptop is funny. I want this to be protected, right, by default. So some entities, some way to add and get this thing, and I'm happy with that. Then inside the collision checker, those are kind of protected. This needs to be static as well. You know, maybe I can type today, maybe I can't. Static collision checker style command to R. What's wrong? It's not in the namespace, right? It's not namespaced correctly. So the idea is that I want to create a kind of singleton thing, like a singleton function, and that singleton function, should kind of just be the static instance of the collision checker, and that static instance would be something that you can query from outside, right? So there'll be no way to default construct this thing, because the constructor is marked as protected, so you shouldn't be able to construct it outside. But calling the static function should get you an instance, or pointer to an instance of this thing, which will construct internally. So nothing else can actually see the implementation of this. All you know is that when you look at it from outside, I can say get me a collision check, and that gets you the one and only one. So let's just do the boilerplate singleton code. If command equals R equals new garbage checker, then simple, straightforward, does not want to compile. Excuse me, just want to I'm assuming this is because I don't have that namespace thing. There you go. So as this thing on, it's inaccessible, but this is That should work, right? Sorry, I didn't have the function namespace and class decoration on here, just declaring a static function randomly. So now there should be a way to say, get me the collision checker, right? So in the collidables, just check the collidable header file, class collision checker. It has this friend collision checker, that's fine, and then the collidable itself just includes that collision checker. So this just does right. Why is this complaining? Oh, it's just IntelliSense took a while to kind of catch up. I have a mouse. Why am I dragging my finger across a trackpad like some kind of wild animal? Let's just do remove collidable. Okay, so I think I left off the last video saying like, hey, I'm gonna show you a fancy way to do this. Here's a fancy way to do this, right? So the collision checker, we don't have a remove collidable. We've got to add collidable. I want a remove collidable, right? So that when these things deconstruct, we can actually just remove them safely. Remove collidable, collision checker, add collidable just does push back. That's interesting. So how do you actually remove something from a vector? How do you remove something from a vector? Auto iter equals entities dot begin for empty iter not equal to entities dot end iter plus plus if I think star iter equal call, and then entities dot erase iter return. That's how you erase from a vector, right? I guess what you actually should do here is you say iter equals entities dot erase, but that's only if you're going to carry on erasing again, so that this check doesn't fail, right? Because this thing, the moment you say erase, this thing becomes invalidated. The internal reference to it becomes invalidated because the actual star iter thing goes away. But if you say iter equals, this erase returns the next item, if I remember correctly. So the next in sequence, it gets the next in sequence, erases this item, and then returns this next in sequence, so that when you say plus plus, it doesn't run off the end of unbounded memory. So the most correct way is to assign to erase. So erase, actually you can see erase returns a iterator, which then gives you all this happiness that actually lets you keep going. So add and remove are there. Okay, this is a great sanity check, so that kind of deals with that. Update intro does, whatever update intro does. Mouse is already handled in mouse move. There is, I remember seeing some kind of latency with mouse move. Just gonna check it again. I'm not too happy or 100% sure about it, but I do know. There we go. You can see that just became valid. So we got the collidable. Let's just go to the ball quickly. Let's just see the ball needs to be updated. We're not moving the ball anyway. There also needs to be a collision response. So let's just go find what that previous collision response was quickly. Let's just close that and close. Why does the zero file contain such a lot of things? Right? Okay, so the ball needs an update, right? We've got update and then we've got mouse. So update, what does update do? Similarity and update. What was this? How many walls do I have? Wall 0, 0. Why doesn't this thing have like a set values function, right? That sets x, y, width and height. Optionally dx and dy. should the collidable should have this function, right? Set properties function that takes these values. Let's just protect it here. Virtual collidable of pure virtual and then public. Okay. Void set values. I know that's not the right way to do it. That's good. Int. Oh, what did I do? Where did my focus rectangle go? Int. I'll show you why now. It kind of solves the problem of collidable CPP. It kind of solves the problem of like, where do we actually go to have all these values set in one go. I mean, obviously the constructor does a great job of setting it all together, but I would prefer if we had a way to do something like this: x equals x, right? Or if you don't want the syntax, I think the compiler is smart enough to figure this out. No, it's not. So let's just name these variables something different. One of the nice things is you can name your externally, you can name your parameter list in the header file. It's the same as your class members, so someone can clearly see it's going to set these definite values. But then yeah, in the implementation side of it, where you don't really expect people to go digging around, you can actually rename these so these don't clash with the class name. So it's something nice. If you look at the header file, the IntelliSense is generated of this definition. And these names, as long as the types and order of the types match up, these variable declaration, these names themselves, this variable assignment name doesn't actually have to match, right? You can call this flap if you want to call it that. It doesn't actually matter as long as the type is in the right type and in the correct order. It doesn't matter. So that's something nice, right? So x equals x, y equals not plus equals underscore. I just want to do it for like every single thing there is. So x, y, w, h, what was it? Dx, yeah, and dy. So now, one of the nice things about this is in the collidable, we got the set values function, and we can actually go here and say set values x, y with height dx, y dx. So paddle dot set values, yeah. Equals static cost that thing what, right? There we go. So yeah, you've got x. I know it's weird, it's a mission. You got h, which is paddle height. So again, you've got this value in paddle height equals. I'm just gonna drag this over there. I actually feel like typing a lot of things today. Today has been a long week. H minus this paddle height thing. I don't really like doing two things together like this, but whatever. X, Y width is paddle width and height is paddle height, and then dx is 0 and dy is 0, and I should solve that. Right. So now, even though we can set them directly, it's easier to just do this. So here we do all dot set values, x, y with height dx, dy. So let's do x, y, width for height for dx, y, dx. Wow, interesting. We commented out the thing that moves the ball around, so it's just sitting there in the middle of the screen doing nothing. Whoa, 0 dot set values, and yeah, it's just something straightforward. So x, y, 2, height 0 0. That's the left wall. Let's just move that over there. X, Y, width, yeah. And then walls 1 dot set values, X, Y, width, height 0 0. That's all solved. Right wall was 0 1 2 dot set values. X, Y, width, height 0 0. Walls have 0 dx and dy. That's normal. Don't want the walls moving all over the place. In fact, we could probably move the walls around to make the stage a little bit harder to play. 3 dot set. That's actually an interesting mechanic. Kind of like a Flappy Bird mechanic, but not exactly. X. Oh, what have I done? Did I just hit the key? I hit the page up key. X, Y, width, height dx dy. As you can hear, the baby's having a lovely time. She's now at the age where she speaks. Partially. Most days it's an attempt at English, and then some days when she's tired, it's just nothing. Just the brain wanting to communicate without finding the words. That's what happens when she's very tired. Okay, so now we have these things happening. So now in this update loop, I think we'll just do all the updates right here. Right? So the first thing we'll do for the ball is I want to move this over here, right? I just want to move that over there so I can have things moving around. Mouse click equal. What does the mouse click do? Does mouse click actually do anything? I don't think mouse click does anything. Yeah, well. So m.sx less than paddle.x plus, we don't know. I think paddle.x is, yeah, paddle.x, paddle.width, paddle.x minus equals 2. I'm wondering if we should just like set deltas on these things. Like my thought would be you set this, you create this thing called a movable entity, and the movable entity just has a direction and a magnitude in each direction, and when you say update, it just does whatever it needs to do, and then you just flip the deltas. Excuse me. That does make it significantly harder, but I mean, I don't mind doing it. I'm just wondering if it's necessary, because it eliminates all this kind of weird error checking and code and whatever. It just does what it does, right? But then what you'd want to say is you'd move everything, you'd update everything, right? So you'd say ball.x plus equal ball.dx, and then ball.y equals ball.dy. But then what you would have is you'd have a get collision man, check collisions kind of thing. You'd want to call that, right? So inside here we're actually getting it. We are getting it, but not explicitly. Let's just explicitly get it. Include collisions, collision checker, right? And then we'll just do we'll update everything here. We'll update all of this, and then at the end of that we'll say, okay, let's do a check. The walls are static, so we don't really update them or anything, we just kind of leave them there. So yeah, I think the simulation doesn't actually resize as you resize. We just draw based on scale. So we draw into this thing and then we scale it over whatever the size of the actual Windows DC comes to. So we have this back buffer with a 320 by 240 height, if I'm not mistaken. Yeah, back buffer with 320 by 240 height, and then we stretch that back buffer over the actual size of the window. So here when we do update and throw, let's just check the update and throw. We stretch split our contents of our DC onto HTC Boston, which is actually the client area DC. So yeah, long story short, we have this little reference bitmap that we draw everything onto. That's 320 by 240, and then it doesn't matter what shape we resize our window to, that client area we measure each frame around, and then grab that DC and then just draw over onto that DC in a scaled blit, right, operation. So that should be fine. So what it means is our simulation is a fixed width and height. So it means once you construct everything, they kind of just stay the way they should. So that's they hold their width and heights, right? So that's fine. Collision checker, get collision checker, check collisions text. No arguments, has no beef. There we go. So now what this should do is give us a moving paddle and have no collision response, I think. Yeah, there's no collision response. Great. That's still so slow, I don't like it. Yeah. The ball's just going to keep going on forever if I don't do anything about it. So the ball should have this, if it hits the ball, right? So in the ball, if it collides, we should get this collision response. So we should actually say, if it hits a paddle, do something, and if it hits a wall, do something. So the ball itself is something that it is governed by dx and dy. So I'm just trying to think, is there a way for us to know which edge hit? No, right? There's actually no way for us to know which edge hit. This collision check is very naive. It just says something hit. That's not right. It should be a collision edge. I think it's the first thing we need to do is we need to define this thing called a collision edge, right? And then the collision edge is going to be relative to the thing that hits. If this thing hits on the left, its collision edge is left, and the other thing's collision edge is right. It makes sense, right? So I guess we'd do something like that. We'd find that intersecting edge, playing field that find intersecting edge of ball. Did we ever have any of this code kind of running, or was this just kind of pie in the sky idea? Yeah, it was a pie in the sky idea. Okay, so this collidable thing now actually has a collision edge, right? So in collision edge, let's just define it left, top, right, bottom, top, right, bottom, left. Yeah, I wanted to say top, right, bottom, left. And I'll show you now why. TRP because if you look at this this frontmost column over here, sorry, can you guys even see what I'm doing? Just scale that up a little bit so you can see what's going on. If you look at this leftmost edge, let me just do this. If you look at that leftmost edge, it says TRBL, which is it's a short name for terrible. It's an acronym, not acronym, but abbreviation for terrible. So whenever you define it, you can define it in a terrible way. That's my little joke. Sorry, I'm exceptionally tired. I've struggled with the Sonar Maven plugin today. It broke my brain a little bit. Top right, bottom left. So when we define here is a get collision response, it actually takes a collision thing and a collision thing, right? And then this ball collided. Top right, bottom left, none. This thing will actually just return an edge that collided here. Ball collided, collision edge collided. I'll show you why now. That. Collision edge collided, return. Right. So this check becomes significantly more complex, right? Let's check the left edge check, right? So what this basically means is we need to check is this thing in range for a left collision, and how do you check if it's in range for left collision? It's very straightforward. So you've got this, just grab this, you've got this, you know, every single time you've got this entity A and you've got this entity B, right? If for these things to be in range, you actually need to know is it of the appropriate height, is it within the same height in order to collide. So you actually need to check is, if you're checking the left edge, then is any of this left edge you know, in this height range of this item. Because if this orange rectangle were down here somewhere, let's just make a new rectangle, make it purple. Actually no, let's make it here. If we naively check is this left edge within the bounds of this object, just in one direction, we say is this left greater than this things dot left and smaller than this things dot left plus this thing dot right. Yes, it is, which means it puts it in this within this width, but not within the height, right? So before we do that funny complicated check, we just check is any of this left edge within the range of this item. I guess what we should first do is now I want to do a distance check, but I don't want to do a distance check like a spherical distance check, just to kind of exclude things early, to say if the midpoint of this object and the midpoint of that object are further apart than this distance, right, then obviously they can't be colliding in any way. Let's try that. So get int, and let's just name it midpoint x equal this dot x plus this dot width divided by 2, and this midpoint y equals this dot y plus this dot height divided by 2. Sorry, it's like a right shift is a quick division. Int other midpoint x equals other x plus other width 2, and other midpoint y equals other y plus other height divided by 2. And now we just get that distance between them. So the distance between the points is what? I want to get the distance between these two things, right? I want to say if it's greater than the width of each item combined, then it's obviously out of bounds. So let's do the horizontal check first. So if integer abs mid point x minus other mid point x is greater than width plus other width, then they are too far apart to be intersecting along the x-axis, right? So return none. That's the horizontal check. If abs mid point y minus other midpoint is greater than height plus other height, then return none. There's no way they can be intersecting. So that's a quick midpoint check. Basically we're saying if the distance between this midpoint and this midpoint is greater than this thing's width and that thing's width, then there's no way they're touching. Right, so this thing's width plus that thing's width. So it's taking this plus this width and that plus that width and saying is it greater than. Once you get closer, then you start running into issues where, you know, this diagonal distance, I don't want to calculate the diagonal distance, I just want to say, you know, a quick exclusion check. If they're too far apart, then won't bother checking, right? So this is a very quick way of excluding them. If they're too far apart, just skip over. Excuse me. So now the left edge check. Is this thing intersecting the left edge? So my frame of reference is going to be this orange one is me. So just put a great triangle inside of it. This orange one is me, and I want to see, is my left edge intersecting that thing? So is this if this thing's height is outside of range, I think it would have been excluded. So here, if this midpoint blah blah blah, it would have been excluded. So now I'm roughly in this range somewhere. I want to check, is this top left or bottom left edge inside that thing, right? So I want to see if this top is below this item, like off the screen, then it can't be it's none. So easy exclusion. If my y is greater than other y plus other height, right? So if my y is greater than other y plus other height, then it obviously can't be a left edge collision. It can't be anything. So, you know, return none. Left edge check says if my y is greater than, then there's no way for it to intersect. So just return none, like just return straight none. And then when I do the reverse, I want to say, is my y plus my height above that other one's y? So if my y plus my height is less than other y, then return none, right? So what I've done here is I've said, is this y, this spot here, this below the screen line, or is my y plus my height, which is this bottom edge, is it above the screen line? In either case, that's an immediate fail, right? So that's a very easy way of checking it. In fact, this should just be called horizontal test, because the horizontal test says if my y's are beyond, right, then there's no way my left and my right could match, right? So now inside here I can do a left and a right check. So here I can do a left edge intersection, and then why like a crazy person, tab, right? Right edge intersection test, right? And then obviously, because I'm not paying attention today, this just completely goes the wrong way. There we go. So if my y's kind of match up, then I need to check I'm running out of time. I don't want to make this a long video. So is the left edge, I'm just going to check do the left right test, top bottom test, and I'm done. It should at least give us a way to tell if the ball should bounce off the walls. I'm not going to fiddle with paddles right now, but it should at least give us an idea of whether the ball should bounce, right? So the first thing we do is we obviously just need to find where the intersections are. So let me just gather my thoughts. A left edge intersection, now that we know it's in the y range, it can definitely intersect. I want to check, is this left, right? So if my left is greater than or equal to other left, and is it greater than or equal to the other left, right? And less than other left plus width, and my x is less than or equal to other x plus other width, right? So if my x is greater than the other x, so it's not off that far in, and my x is less than or equal to the other x plus the other width, then I can return left immediately. I know that edge hit. I guess the same for the right intersection, right? If my x plus width is, if my x plus my right edge x plus width is greater than or equal to other x, and my x plus width is less than or equal to other x plus other width, then a right intersection, immediately return right intersection. That's fine. So that is a quick exclusion, right? We do the midpoint check, then we do the horizontal test. If it's completely out of bounds, then just quick return. And now we're going to do this comment doesn't make sense anymore. This entire block corresponds to the horizontal test, so this comment should actually go here and move the crazy person. There we go. So that is a left right test. Let's just do the vertical test. So let's just do vertical, and then for vertical, if my x is greater than other x plus other width, right? So if my x is greater than the other x plus the other width, it's outside of that object, return none, it can't be hitting. And if my x plus width is greater than the other x, so if my x plus width is the right edge is less than the other's x, it's off that edge, return none. It's a quick exclusion. And then I want to do a top edge intersection. So if my y is greater than the other y, If my y is greater than or equal to the other y, my y, they in line like this, and my y is less than the other y plus the other height. So my y is less than the other y plus the other height, then it means my top edge is intersecting that other bounding volume, so immediately return top. And then the bottom edge intersection should be something similar. Bottom edge intersection, so if my y plus height is greater than other y, and my y plus height is greater than other y plus other height, then it means the bottom edge is intersecting. Right, so that should take care of all the little edge cases all together. And then this check itself, let's just comment it out for now. We'll do some cleanup towards the end, but that gives me a way to actually return a collision edge out of my collision detection function, so that when I shoot, that's not a void collision response. Let's just go look at that interface quickly. So when I say collision response, it takes collision type and collision edge, right? Let's just go through the checker. This becomes a difficult thing to kind of emulate, right? The collision type should be horizontal. Two entities collide. So I'm just thinking, how would you actually handle it? Let's do that later. Let's first do virtual weight collision response, collision type T, collision edge E, collision edge E. Right. So let's just do this for ball and all the other things. Control C. So what did I have? Ball, brick. Just want to make sure the interface is correct at whichever time that I need it. Huh? I think most of this is overkill, because the only thing that actually needs to do anything special, you know, when a collision occurs, is the ball and the brick. The walls and the paddle don't really do anything. Although the paddle does count. The paddle does contribute towards the score. But you could do that in the ball as well. But I want the ball to manage its own changing direction, and then paddles and bricks contribute to the score. I think that should be fine as is. So that's fine. And in the collision checker, we actually need to say collision edge E equals entities I collided, then if E not equal to collisions none, right? Now we handle the collision response. So the entity I returns which of its edges collided, right? So this would be E, right? Then the thing it collided with actually gets a copy of a complementary edge. So collisions, one day I'll be able to type complementary edge. Let's just do camel case for now. I know, yeah, that's actually right, equals. So let's just do some ternary magic here. If E equals left, then return right. If equals left question mark, return right. Else E equals top, return bottom. Else return top. So if E is left, return right. What if E is right? If E equals, let's just do this. If E is left, return right. Else, if E equals right, return left. Else, if E equals top, return bottom. Else, if E equals bottom, return top. Else, return bottom. It's crazy. How far can you nest that? Like, it doesn't make sense. If equals left, return right. Also, if equals right, return left. That's fine. Or if equals top, return bottom. Else, if equals bottom, if equals top, return bottom. Left, right, right, left, top, bottom. So if E equals top, return bottom. If it's not bottom, just return top. It should be straightforward enough for anyone to look at. And then the collision response for the other entity that it collided with gets the complementary edge. Type correctly, thank you. Great. So now this thing knows which edge hit, and that is great because what happens is we can actually now go and affect the way it interacts with the world. So in the case of the ball, right, you can actually do something like switch E, say, you know, case top, then it's dy should equal, what is this, minus dy equals dy less than 0, dy times minus 1. Else just dy. Right, so if it's less than 0 multiplied by correlations, you can do stuff like this, right? So you can say like, I want this thing to do whatever. So case correlation bottom, you know, my dy equals dy greater than 0, yes, then dy times minus 1 else dy. Case, wow, one day I'll get this right. One day I'll get the hang of this typing thing. Left, if dx is less than 0, so if it's going this way and it hits its left edge hit, then move it right. So dy less than 0, question mark, then dy times minus 1 else, not dy, sorry, dx. Dx less than 0, look at the minus 1 else just dx. Yeah. We should never get into this x case. The left edge should hit when it's going the left direction. So break case collision right, and you know the dx should be if the right edge hit, then it means the dx is greater than 0. So you know dx greater than 0, dx times minus 1 of dx. That should be 5. And then the default, I guess, is just do nothing, right? So default, just break. And that's what the ball should do if it hits something. The paddle should do nothing. The bricks should do something. So if there's any kind of collision between the bricks, then it should do something. So what is it actually going to do at this point, right? I'm not too yeah, something's clearly wrong. Something's like clearly wrong. Let's just run it again. I didn't even look at it. I just know something's wrong. So there, it hit the wall and didn't do the thing. Yeah. So let's just debug it. See what's going on. Here we go. The ball hits the wall. Huh. Why doesn't it determine that it hit the wall? This is very concerning that it doesn't determine that it hit the wall. Ah, there we go. So if it's not equal to none, do the thing, right? There we go. So what is E left? What is hitting left? I can't see. Let's just do this again. Let's just grab that here. Ugh, I can't even see what's hitting. Oh, the paddle is hitting the left edge. Okay, so I'm not too stressed about that. But what this means is basically what's happening is because the paddle is hitting the left edge of the wall, the paddle doesn't have a collision response yet. The paddle's hitting the left edge of the wall and it continues to hit all the time. But then when the ball hits something, it's not determining that the ball is hitting something, right? So it's actually this paddle, because I had a return earlier there, it's not actually doing the thing. There we go. Now it's doing the thing. Right? That took a while to process. So let's see. Now the ball bounces around. The paddle is crazy slow. I'm not gonna lie, it's stupidly slow. I want this to be faster. I'm not even sure I'm getting my full 30 FPS. I don't think I'm getting a full 30 FPS. What I am getting though is I got a bottom edge detection. Did I get a left edge detect and then it flipped around? Yeah, you can see it's not doing the thing it's supposed to do. Even though I checked vertical first. Yeah, check. It's doing left right detect first and then top bottom. Let's just check the collidable. Collidable does if the left edge hits and then it should do the vertical test. So what it should actually do is all in one, I guess, right? Or if you want to be lazy like me, you can just flip the tests around. Like check the top and the bottom first. Let's see if that does what I think it does. But as you can see, there's a lot of pitfalls for the AABB testing. I think the interesting thing we did today was the check for the way of getting our static instance, our singleton up and running. The vertical test doesn't seem right. Yeah, there is something funny with this collision detection, but I'm kind of happy with where this is right now. If the intersection is the top edge, then just flip the dy around, right? So the right is working, but the top edge intersection isn't working. So this top and bottom edge intersection isn't working. Let's just check the ball quickly. So if it's top and if it's bottom, we should at least see something here for top and bottom, right? So if it's the top colliding, if the dy, right, then y plus equals to dy, it's the bottom, same thing, y plus equals to dy, that moves it away from the edge where it is, x plus equals to dx, and x plus equals to dx. That should move it away from the edge that's intersecting, right? So let's just see. I'm curious if that actually solves it, because if that solves it, then that's great, right? Move it. The collision response for the ball should be move away from the edge that you're hitting, right? So let's see, move it away in the y direction, move it away in the x direction. So now the next step, the collision detection should say y hits, move it away, right? Flip direction, move it away. But then it's still getting a left edge hit, so that's not right. There, it immediately gets it right. Okay, so dx is -1, so dx becomes positive. So now x why is it a left collision? E was a left edge, yeah. It's a cool stack. Oh, it's not gonna take me into that entity collided. Why though? I really want to solve this. So the vertical test checks. Let's just grab the top edge intersection. It's actually, let's run it, and then it gets the top. That's weird. That should get a right. That's actually very interesting. So the ball isn't doing the correct thing. The ball is saying my bottom edge hit because the bottom top test is running through first. Let's just check it. Vertical test. Yeah, the bottom top test is running through first. So the horizontal test is for the walls. This makes sense, right? The wall has a leading edge and a trailing edge. The leading edge, the major axis for a vertical wall, the major axis is the y-axis. So you would most likely always get a left-right hit on a wall right away. If it's a horizontal wall, you get a top-bottom hit on a wall. That makes sense. But for a ball, sorry, the hit itself is determined by the direction. Let's just see how we can simplify this logic a little bit. I'm very, very upset about this, right? Yeah, see, this is rudimentary. This is incredibly rudimentary. This just checks, is it hitting the bounds, then flip the direction, is it hitting the bounds, flip the direction. It's not actually showing me, is it... let's just see what it's doing. Yeah, where's my... Yeah. Collidable. Not to test. If it's beyond those bounds, let's just continue, and then it hits the vertical edge. Okay. Interesting. It's way inside that bounds for a long time. Should I exclude the paddle from this? I guess I could exclude the paddle from this. I don't want to sit in this loop forever. Yeah, so if it's going towards the right, it's going towards the right and the bottom, right? It's going towards the right and the bottom. Oh, this is interesting. So this thing is going towards the right and the bottom. So what's happening is this right edge should be detected, right? So let's see what's happening. Collidable. So let's see, we did the midpoint check, we said yeah, that's fine. So we do the vertical test. So it says if the x is blah 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 and the x plus width is blah blah blah, return none. Alright, now that's this top edge intersection. But that is correct, that is perfectly correct, right? So it's saying it intersected. And what's happening, I think I know what's happening is, this is something interesting. Let's just delete all of this, let's start fresh. So you've got this thing, you've got a wall over here, it's this size, and then you've got this ball over here, it's this size, right? So let's just do that intersection over there. Because we're doing the top check first, we're saying this bottom right edge hit correctly, right? So we're saying oh, this is hilarious. This is something interesting. So it's saying, are these x's saying yes, it hits? So it hits along the left or the right edge, yes, right? So it says, okay, well, because we're doing the top check first, it actually says yes, this x is within this range. So let's see if the top is hitting or the bottom is hitting. So it says, you know, because I do this check first, it is within the bounds. This top edge is within the bounds of this thing. It's definitely hitting. So there is a way to solve this. I don't know if I'm patient enough to solve it, but there is a way to solve it. So what we would most likely do is we would say we get the collision edge. And because the direction is down and right, if it's down, we need to check if the edge is bottom. If it's right, we need to check if the edge is right. I think that's the easiest way, because the intersection test is correct. It's actually saying yes, bottom and right edge is intersecting. We could get a list of collision edges. I mean, there's nothing stopping us from doing it. So, ooh, I've seen other libraries. These rigid body motion libraries. I've seen them do things like return a bit field to say, the left, the top, the right, and the bottom colliding or touching something. We could do something like that. We could say the right and the bottom edge are touching. That would kind of solve it, because you can have more than one edge touching. It's not just like one edge that's touching. It's actually a bunch of edges. So what we would want is we want to return a. I'm gonna have to be quick about it. I'm way outside of my time scope for this, but we would most likely want to say that there's a list of edges. I want to do a bit field, but I don't want to do a bit field, so let's just do a just the struct collision the edges pull top or the pull terrible, right? Terrible, yeah. Collision edges struct, right? And then that collision edges would actually just return that collision edges struct. So this collision edge itself, let's just refactor that away, right? I know. I don't like it, not one, but let's just do this. It's such a heavy structure to such a heavy thing to return 4 booleans, right? Whatever. So this thing would return a collision edges structure. So collision edges. Collision edges. It's just going to return by value, so that's fine. So then the interface itself is okay. I still don't like it, but I think this is actually how other libraries do it. What's that library called? Collidable. Let's see. Yeah. So edges. Yeah. Let's just say edges equals, let's just say all false. Right? Equals. Oh, I need a name, right? Red for red value. Okay, return red and return red. Okay. So if the x is way out or the x is way out again, just return red and return red, right? But then yeah, the vertical test should say if my top edge intersects, I can't return that. What I can say is I can say red dot top equals true, right? And then here just say return red. Same thing here with this check, red dot bottom equals true, right? Same thing with the horizontal test, just return red, because there's no way the horizontal edges could be intersecting, but if they are within that bounds, we can actually say, but red dot left equals true. It's my left edge equals true, because then in the ball we can decide that based on the direction, we can do something special. Let's see if the major direction was right and the right edge hit, then pivot left. If the major direction was bottom, the bottom edge hit, then perfect. And if the direction was right and bottom, and one of the edges hit, then do some stuff. So that kind of solves this problem where previously we had to check the edges in order, so top, right, bottom, left. We can actually just be smart about it. Now we can say like all these edges hit. If we want to, we can say all the edges hit. I'm a little bit concerned about these early returns. They might just kind of bust the test up. I'm not gonna be too hard on myself about it, but I do feel like there is some potential, right? Collision edges E equals collided. If E dot top or E dot T or E dot bottom or E dot left. Right, so if any of these are true, no, that's clearly going to do something weird. So if any of those are true, then we definitely got a collision response. So you just get a collision response. Complementary edge equals and collision edges comp dot top equals not E dot top, but can't I then just do this? Top, right, bottom, left, not E dot top, not E dot right, not E dot bottom, not E dot left. As you can hear, it's raining very nicely. So let's just kind of make sense of it. So terrible. So you not it. So if it was true, it becomes false. If it was false, it becomes true. Yeah, I think that's how you do it. And then just pass comp in there. Right. And now with the only thing that actually implements it, we can actually say collision edges E. Okay. So you can actually do if this logic becomes convoluted. If E dot top break becomes not, and same thing here. If E dot bottom break becomes not, and if E dot left, I think this behavior should look almost exactly the same as what it was if E dot right. And then do this. Oh, right didn't have a break, right? Just went straight to default. This should give me identical behavior. Like it shouldn't do anything different, except for there's no fall through. So let's see, collision edge, collision edges, brick wall, collision edges. As you can hear, it's really coming down. Battle, collision edges, brick collision edges. Oh, I did brick collision edges. Do that. It should give me identical behavior, except for the fact that when it hits, I should get a proper collision response. Yeah. So I now need to just do the actual check that says if I get a left edge hit and the direction was left, then do the thing, right? Simple as that. Yeah, you can see it's bouncing in like weird directions. I think it's gonna get stuck there. Yeah, that's the order of the check. So all I need to do in the ball, now that we have a way to detect multiple edges hit. So if E dot top, if the top edge hit and my dy was going up, then do the thing. If E dot bottom and my dy was greater than 0 because it's going down, it's plus plus, and E dot left and dx was less than 0, and then E dot right and dx was greater than 0. I think that's just gonna make it do the thing now. I think if I got my, did I get my cases mixed up? If I got bottom and dy was greater than 0, yes. Oh, it was going that way, and then I gotta left it, and left dx is definitely less than 0, so it is. That's interesting. So why is it moaning? What does E look like? Top and right. Oh yeah, top and right. Looks okay, top and right. Is my right check correct? I should actually add a unit test. I should figure out a way to do unit tests. So my top and my right says yes, right? So it says top and right definitely hit. But because it's top, it's gonna say go down. And if it is right, it is going towards the right, so it's gonna flip it to the left. So should I break? Or should I just return? Should it be else if? This one actually has me stumped. This one definitely has me stumped. Let's try that. I'm not convinced that's gonna solve the problem. Oh, no, not even close. Oh, I dropped my tissue. Bottom and right looks okay. Still not convinced. Top looks okay. Oh, the top goes the wrong way. So if my top hits, it says just my top hits, and it says just my left hits. Oh, and then there, it goes right. Oh, I didn't detect right. Dx was definitely greater than 0. Why didn't it detect right? Okay, so there's an obvious problem. There's like a very much obvious problem with it. I'm getting multiple edges. I'm able to say my top and my right have hit, right? And I'm able to say if let's just see, if dy is greater than 0, or let's just flip this logic around. If dy is greater than 0, heading down, if y plus equal to dy is heading down, right? If it's heading down and I get a, if e bottom, then dy dy equals minus 1, y plus equal to dy, and that kind of ends it, right? Else dy was heading up, and if e dot top, if it's bottom or right or left, whatever. Let's just focus on that. So if it's going up or down, then if it's e dot top, then it's the same logic, right? So dy equals 1, y plus equal to dy. Oh, interesting. If it wasn't button and it just returned earlier, it should only return in case it actually hit return. Yeah. Return. I'm having such an interesting day. So yeah, we do if dy is greater than 0, else do that. It didn't hit that. It didn't hit that all double bottoms. So it says if dx is greater than 0. Anything right. Now it says if e dot right, yeah, so if e dot right, then dx equals minus 1, x plus equals to dx, return, and when it does else, the dy was obviously different directions. If e dot left, dx equals 1, x plus equal to dx, return. I think that's the simpler logic, right? Because these AND relationships are just messing with my brain for a bit. I shouldn't have just started coding blindly. I should have actually gone and done some research about how this all fits together. So yeah, it's heading downwards, right? So now it does a check. Are you heading downwards? Yes, bounce. You heading right? Yes, bounce. Right? Are you heading top? So it's just flipping the check around to the major axis. So are you heading up? Yes. Are you heading? Oh, interesting. Are you heading up? If e edge dot top, why does top not trigger? There's a thing wrong with the collision response. That's actually what's wrong. The detection's off. I can prove this. The detection's off. So let's put that breakpoint here on top. Yeah, so you get it right. Yeah. So if dy is greater than v dot top, right? Yeah, that's garbage. The top is false, right is true, and bottom is true. Okay. Let's just continue. Yeah. So this should go in and say my top hit. Yeah, say my top hit. So dy is currently minus 1 equals 1. Now it moves, right? What is other? Other should be a wall, right? One of them is a ball. What is this? What is locals? Locals is this is a wall. Right? So this is a wall. So the walls it hit on the top. So the wall's bottom edge, which means either top should show. So the wall's bottom edge hit. So yeah. My point x is 120. Okay, and then the other midpoint is other width, other height, other x, and y. Yeah, that makes sense. Oh. If this is a horizontal wall, right? So its midpoint 319 minus 131. Is this midpoint check just screwing it up here? Let's just if false. Let's just ignore this midpoint check against the walls doesn't actually make sense. Right? I'm very much not into the idea of that midpoint check. It's nice in theory, but in practice, doing the midpoint check against the wall doesn't actually make sense, right? Let's just see top hits. What does it do? Yeah, okay. So the first issue that I see is the midpoint check must go over. Okay, great. That's a step in the right direction. So the midpoint check at least gives us something useful. So top and bottom are definitely flipping correctly, right? Oh, that's interesting. Are you seeing that? Something is reporting that it's right there on the screen. Something is very much reporting the incorrect width and height. Okay, so this makes me happy. So we can clearly see that something is reporting. This is partially why we're getting like weird results, because something is reporting it's incorrect or width, height, etc., etc. So what is that? I don't have much time, but what I'm going to do is this. Dx times equal minus 1 x plus equal to dx times equal to minus 1 x plus equal to x, and if it's right, dy. If what's the top of the bottom? The direction shouldn't change. Let's not do anything weird. Just deal with each direction at a time. Something is reporting it's there when it's not. So let's just dump all this logic. We've clearly seen that logic isn't 100%. Something is reporting it's there when it's not. So in a collidable, if false, we take out this midpoint check. This vertical test I should just comment this out completely. Like every time I look at it, my brain just says, look at this, right? My brain just says, like, look at this. It's doing something. If my y is greater than y plus other height outside, it can't possibly be in the thing. If my y plus height is less than other y, can't possibly be inside, right? And then it has the left edge. So if my x is greater than other dot x and my x is less than other x plus other width, my x is greater than other x, and x is less than other x other width. Yes, that's a left intersection. And then same with the right intersection. If my x plus width is greater than or equal to other x, and my x plus width is less than other x plus other width, that's alright. Okay. And then here for I want to flip this check around. I should do. I don't like the way that other intersection tests works. I'm not too happy with it. But what I should do is flip those intersections around. So I should say this top edge, if my x is in range, then check the top edge. So if the x is greater than other x and less than other x plus other width, right, then check the top edge. So what this should look like is, if left within range other and right within range other, then check the top edge, and if the top edge is in the thing, then true. So actually let's just add something to the collidable. Left within range, right within range. Let's just do private. Yeah. So pull left within range. Other left, right, top, bottom. Actually, it should be top, right, bottom, left, right. Let's just grab these. This is, I like this much better. It's a little bit more broken down. So this is the last change I'm making here, just to kind of solidify the logic a little bit, right? Collision is collidable. Did I not copy it? I did. So all I'm going to do here is do this check. So collision collidable that. So left within range is actually return if my left is within range of the other. So if top within range, return my top edge is within that range. So return y is greater than or equal to other y, and y is less than or equal to other y plus other. Right, simple as that. Right. So return that and that. So that tells you if the top is within range. Right within range just tells you x plus width is greater than or equal to other x, and x plus width is less than or equal to other x plus other width. And then the bottom within range simply tells you turn y plus height is greater than other greater than equal to other y, and y plus height is less than or equal to other y plus other height. And then left within range just tells you, so top is y, height is x plus width, y, bottom is y plus height, and left is x is greater than equal to other x, and x is less than equal to other x plus other width. Okay, so now those midpoint checkers, just I don't know why, but it's crazy. It doesn't make sense. And this check also doesn't make sense. So if left within range and right within range, then if top within range other red top is true, the bottom in it, sorry, I just want to kind of think about it really hard. If the left and right are within range, then check if the top is within range or if the bottom is within range, right? And then the same thing is if left and right, if top within range, other, and bottom within range, other, right? Then if left within range, other, red dot left equals true, if right within range, other, red dot right equals true. And that takes care of that entire set of intersections. So now with this logic, let me just check it. I still don't believe it's going to actually fix this thing, but what I believe it's going to do is it's going to give me a way to actually look at it and say, is it simple enough, right? I'm not too convinced it's simple enough, but basically it's going to first check the top and the bottom and then the left and the right. Okay, so the order of operations is incredibly important. It actually looks like if you do the range tests properly, then you end up not having stupidly weird like simulation glitches in like the friggin' middle of nowhere. It actually doesn't make sense why it was glitching in the middle of nowhere. It didn't functionally change anything except for just computing the bounds a little bit more cleanly. I think this is a little bit cleaner just with these names, and it's a little bit more clean with the set of utility functions. So this actually makes me slightly happier that you can see the ball is actually bouncing around correctly. The paddle is still doing just like a squat, but I'm fairly happy with how that turned out. So today we did AABB proper testing. We did full on collision detection. The main check happens at the top level inside the collidable. And then the ball itself just has logic that says if the top is hitting, then flip the direction over. If the bottom's hitting, flip the direction over. And then I guess the same thing for the paddle. So if it is hitting something, then do things. I think the very next check I need to do is there a way for it to hit the paddle? I don't know. I don't think I actually coded anything. And the paddle is like crazy slow. Like this is slower than I would hope for it to be. Like, oh, but actually it's the paddle. So we got a 2-for-1 freebie there that hits the paddle. So I'm kind of happy with that. So I think I'll stop here. I'll make the source code available. I think I've got a link in the description somewhere. So I'll make the source code available. You can follow along. I'm not going to do any cleanup in case I come to this like 8 months later. Hopefully not. But I'm not going to do any cleanup. I'm just gonna kind of leave it like this. It's a very interesting exercise to see how you go from I don't know why it's broken to I don't know why it works. And I'm kidding. I know why it works. The initial not knowing why it's broken is just because I haven't actually done a game like this that does a proper collision test. Because what this actually means is that I can put in now that the tests are actually sorted out correctly, I can put walls into the game, like random walls in the level, and it should collision detect against the ball easily. So I think that's the next step for me, is to put the bricks in and get the score up and running, and then get the couple of walls in for maybe the next stage. And then I'm happy. I think that'll get us on par with the JavaScript one, because the JavaScript one was just a bunch of naive tests. It wasn't anything like well constructed. I didn't really have the time or the resources to sit down and actually figure it out properly. So I kind of just jumped in, threw myself at it, wrote a bunch of naive tests. I mean, we saw the naive tests working here before I started refactoring and cleaning it up. But now that it's refactored and cleaned up, we can actually do interesting things. I think that for the next video, we're probably going to add in like a FPS counter just to see why things look and feel so slow. I think there's definitely something that's not right because I can clearly see that this isn't right. This isn't even smoothly double buffered. So I guess I'll add in something like that at some point. But for now, I just want to get the simulation of the game correct. Paddle movement, I'm not happy with either. It should track one to one with the it should track one to one with the mouse. It should be, this is like plain GDI. We're not doing anything special, so it should be a lot faster than this. So I think next time we sort out all those weird inconsistencies, track down the source of the slowness, try and debug or profile this, and then maybe just add in those bricks quickly next time, and then I think done. Uh, Thank you for coming on this journey with me. It's a long, freaking hard day. Like it's been crazy, but I think today we actually solved it. I think the last video I said I want to make this thing move and bounce. I think yeah, after 8 months I came back and I made it move and bounce. You all came with me for the journey, and now we have a very nice, little system that kind of does what it should do. The collidables actually neat. For one flipping time in my life, I did it right the first time. Or not right, but I did reasonable the first time. I split it up small enough so that the logic is composable. This is called composable logic. You can say if left and right, then if top, then top, if bottom, then bottom. It's composable logic with utility functions. It's neat. It's neater than it previously was. This interface is as clean as I'm gonna get it. The collision edges are, I'm happy with this. Instead of saying, a left and a right, just here's a structure you can pass around. It's passed by value, not by reference or by pointer. It's passed by value. So it's just a little copy of this thing happening every once in a while. That's fine for something like this, where we know that we are going to limit the amount of copies of this that's made. I'm fairly happy with this. So I think we end there, and we call it a day for now. Thank you very much, everyone. As usual, like, comment, subscribe. And let me just end my video off with my get off my screen. No, don't save those changes. Get off there. End the video with these pretty stars. Have a great one. Cheers.